Hey guys, this is Coach Lowe and this is Contextual Geometry, and we are going to start Chapter 8 today, Quadrilaterals. So in your notebook, if you will just put on your next page after Chapter 7 has been over, if you will put Chapter 8, Quadrilaterals, and then leave that page blank and go ahead and go to the next page. I have something for you to glue in your notebook on that page. So your next page after Chapter 7 was finished, Chapter 8, Quadrilaterals. So you're going to write Chapter 8 at the top of the page, quadrilaterals, and then you're going to leave that page blank. So let's go ahead and go to the next page, and we are actually going to talk about the definition of a quadrilateral. So leave the page blank that you have Chapter 8 quadrilaterals on, and on the next page you're going to write 8-1 quadrilaterals. So quadrilaterals, quad meaning four, we have a four-sided figure. This is a closed figure, and by closed figure we mean all sides are touching, all there's no openings, there's no spaces, everything's touching. We have four sides, we have four vertices. Quadrilaterals can only intersect at their endpoints. So let's make a yes and a no section. And let's draw some quadrilaterals. So you can draw something crazy. As long as it has four sides, we are good to go. All right. We could draw a square would work, or a rectangle. Those are both quadrilaterals. Parallelogram is a yes. Trapezoid is a yes. All right. Not quadrilaterals. Well, if it doesn't have four sides, it's not a quadrilateral. If you have some crossing, even if it does have four sides, we have intersection not at the vertex right here, and so that's a no. Or if it has curved pieces. So not a quadrilateral, right? Even though it has four pieces, they're not four sides. We have curves here. So this is a no. All right, so hopefully you can see the difference between a quadrilateral, whether a figure is a quadrilateral or it is not a quadrilateral. So we're looking for four sides, four vertices, um, sides intersect only at the endpoints. Oh, and it's a closed figure, right? We talked about that at the beginning. I'll draw one over here that's not closed. 1, 2, 3, 4. That's not a closed figure. Four sides, but I have this gap right here, so it's not closed. All right. Make sure if you have questions on that, you make yourself a little note and ask me when I see you again. All right. Next thing. Quadrilaterals are named by their vertices, and we list those vertices in order. And it doesn't matter where you start or which direction you go, but once you start a direction, you've got to stick with that direction. All right, so this would be quadrilateral, and we could start anywhere. We could start here at B, and we can go this direction or we could go this direction, but we have to go to the consecutive vertices. That means one right after the other. So let's say that I start at B and I go to my left. So B, A, D, C. So you have to travel around the quadrilateral. You cannot travel through it to get to the next vertex. All right, so again, it doesn't matter where you start. We could have started down here at D, and we could travel to the right, or we could travel to the left. So we could have quadrilateral D, A, B, C would also work. We just want to make sure we're traveling on the outside of that quadrilateral. All right, so speaking of consecutive sides, any two sides that you choose, any two vertices that you choose, any two angles that you choose. You have two choices. They are either consecutive, I didn't get a C in there, or non-consecutive. So either they are right next to each other or they're not. So angle A, consecutive with angle A would be one right next to it. We could have angle D or we could have angle B. Non-consecutive with angle A would be not right next to it, so it's going to be across, like the diagonal, looking across. So non-consecutive with A would be angle C. All right, let's try a side. Side AB. Consecutive to side AB. So here's side AB. Consecutive to side AB would be side AD. Or, what's the other one? Yeah, side BC. It's touching side AB also. All right, so there are the sides that are consecutive. They are touching side AB. So which is the non-consecutive side to AB? Yep, DC. Good job. All right, and then vertices. So let's pick vertex D this time. Consecutive to vertex D would be A and C. Non-consecutive to D would be B. It's all the way across. It's not, there's that one that's right next to it, and then this one's next to it. It's one jump away, two jumps away. You have to go here and then here. So it's across at the diagonal, so it's non-consecutive. All right, now that we've talked a little bit about diagonals, a diagonal is drawn from one vertex to its non-consecutive vertex. Let me get a new picture here. And you could draw any random quadrilateral that you want to. All right, so diagonals join non-consecutive vertices. That means if it's not one right after the other, we can join them and make a diagonal. Notice, if I try to join consecutive vertices, it's just the side of the quadrilateral. I want non-consecutive vertices. That gives me the diagonal. All right, so in this picture, AC is a diagonal. What other diagonals could you draw? How many more can we draw here? That's right, we can draw one more. BD is the other diagonal. So BD is my other diagonal here. All right. Awesome. Let's keep moving. The last thing that I want to tell you in this section is when we have a quadrilateral, well, first of all, you know, inside a triangle, the sum of the three angles inside a triangle is 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C is 180. We know inside every triangle, 180 degrees. Well, let's talk about any quadrilateral. The sum of the interior angles in a quadrilateral, let's see if we can figure this out without me telling you. If we think about this as how many triangles could there be in this quadrilateral? If I draw just one diagonal, how many triangles do we have? Two triangles, which means the sum of the measures of the interior angles in a quadrilateral have to add to be 2 triangles. Well, 2 triangles is 360 degrees. So any quadrilateral has to add to be 360 degrees. The sum of the interior angles have to add to be 360 degrees. All right, let's practice on one. Let's say we have quadrilateral KLMN, and I want you to find the measure of angle M if the measure of angle K is 2x, the measure of angle L is 2x, the measure of angle M is 2x minus 20, and the measure of angle N is 3x plus 20. You guys know I'm going to draw a picture, right? Random quadrilateral. K, L, M, N. 2x, 2x, 2x minus 20, 3x plus 20. All right. So what do we know about these interior angles? The sum of all 4 angles has to be equal to 360 degrees. All right, so we need to add all of our x's, combine our like terms here. Add all of your x's together. 2 and 2 and 2 is 6, and 3 is 9. So 9x, now let's put all of our numbers together. A minus 20 and a plus 20, that's convenient. That's just a big fat 0, isn't it? Same side, we're just combining like terms. So now equals 360. All right, let's solve for x, so we'll divide by 9. So x equals 36 divided by 9 is 4, and then we have a 0 there. So x is 40. They want me to find angle M. Angle M was 2x minus 20. So I want 2 times x minus 20. 2 times 40 is 80, minus 20 is 60. So the measure of angle M is 60. We could find every single one of these, couldn't we? Why don't you go ahead and do that? Pause the video and go ahead and find the rest of these angles. So now that you're back, angle K is 2 times 40, which is 80, and so is angle L. And angle N is 3 times 40 plus 20, so 120 plus 20 is 140. All right, so we will work some problems like these in class, similar to these. Remember, if you have any questions, please write them down somewhere in your notes, maybe with a little star, so that you can ask me when you get to class, when I see you again. So I need you to put a, let's see, what should we put on ours? In the bottom left corner, put a P for prior and show it to me when you get to class. All right, guys, this is Coach Lowe, and I'm out.